Quick question to start. If I asked you to picture a really tough problem, what's the first thing that pops into your head? If you're anything like me, you probably imagine some big, intimidating math equation. For a lot of people, math is the poster child for difficult. It's abstract, it stacks complexity on complexity, and because of that, tons of people quietly decide they're just not a math person, which is flatly not true. Math is a skill, and skills are learned. Nobody is born knowing calculus, the same way nobody is born knowing how to ride a bike. But since you clicked on this video, I'm guessing you already believe that, at least a little, and you've got the motivation to actually improve. So let's answer the obvious question. How do you get better at math? The honest answer is almost annoyingly simple. To get better at math, you do lots of math. And the harder the problems, the better, because tough problems are the ones that stretch your understanding and force the breakthroughs. But here's the thing. As you work through those hard problems, you're inevitably going to hit ones that completely stump you. Total brick wall. And those moments are exactly where the growth lives, if you know how to handle them. So that's what this whole video is about. Practical techniques for working through the problems that look impossible at first glance. I want to start with a piece of wisdom from the Hungarian mathematician George Pólya from his classic 1945 book, How to Solve It. The gist of his most famous principle is this. If you can't solve a problem, then there's an easier problem you can solve. Find it. That idea is the backbone of everything I'm about to show you, so hold on to it. Technique 1. Break the problem into single concept pieces. This is, in my opinion, the most important one to internalize, and it works because of how math is built. Math is cumulative. Complex concepts are constructed out of simpler ones. So if your grasp of a fundamental is shaky, a harder problem that relies on that fundamental is going to wreck you, and you won't even be sure why. So when you hit a problem you can't solve, step 1 is to identify the separate components or operations it's actually asking you to perform. Complex problems usually bundle several together. Then you split that one hard problem into multiple simpler problems, each isolating just one of those components. Let me show you with an example. Say you've got a summation problem, the one with the big Greek sigma that tells you to add up a series of expressions, but this particular one also has a fractional exponent buried in it. Now, maybe you're a wizard and you can do both in your sleep, but it's entirely possible you're not rock solid on summation or on fractional exponents, and when a problem fuses the two, you freeze. So you pull them apart. First, make a stripped-down summation problem with the fractional exponent removed entirely. Just practice the summation by itself until it's clean. Then, separately, drill the fractional exponent on its own. Two simple problems, each training one muscle. The key word there is mastery. The entire point of those single concept drills is to master the underlying operation. And mastery has a specific definition I want you to remember. Mastery isn't getting it right once. Mastery is not being able to get it wrong. If you solve a couple and still feel wobbly, keep going until it's automatic. Because here's the payoff. Once each isolated concept is something you can do without thinking, you go back to the original combined problem. And now all of your mental processing power is free to focus on the genuinely new challenge, which is how those concepts interact together. You're no longer spending brain power on the basics, you've made room for the actual hard part. There's a second simplification trick hiding in that example, and you might have caught it. I deliberately used small, clean numbers. No ugly decimals, no giant fractions, no huge summation limits. That's intentional. Big, messy numbers hijack your attention and drag it away from the concept you're supposed to be practicing. You end up grinding through arithmetic instead of learning the actual operation. So if you're stuck on a problem stuffed with nasty numbers, rebuild a twin version using tiny whole numbers you can manipulate in your head. Same structure, same concept, none of the distraction. Technique 2. Know when it's time to go learn. Sometimes the issue isn't that the problem is complex, it's that your understanding of the underlying concept is genuinely too thin to work with at all. And that's fine, that's just a signal. When that happens, stop grinding and go learn. Dig into your textbook, comb through your notes, or find worked example problems online that you can follow step by step to see how people actually apply the concept. And if you need to, you can pull up a full step-by-step solution to the exact problem you're stuck on. There are some genuinely great tools for this. The two heavy hitters are still Wolfram Alpha and Symbolab. Wolfram is more powerful and computationally capable, though its step-by-step solutions sit behind a paid tier, while Symbolab's interface is a touch clunkier but gives you steps more freely. If you want something completely free, Microsoft Math Solver gives full step-by-step solutions at no cost. And if you do your work on paper, PhotoMath lets you just scan a handwritten problem with your phone camera and walks you through it. But, and this is critical, there are two huge caveats to using these. First, before you go running off for a solution, ask yourself honestly, have I actually pushed my brain to its limit on this yet? Because the mental strain of fighting through it yourself is the entire thing that makes you better. Looking at a solution doesn't build the muscle, struggling does. There's real research on this idea, productive struggle, sometimes called desirable difficulty. And the short version is that the effort of retrieval and problem solving is what cements learning, in a way that passively reading an answer never will. Second, if you do look up a solution, that's okay. Follow the steps, make sure you actually understand how the answer was reached, but then close it and rework the entire problem from scratch with no reference. This matters more than almost anything else because math has a sneaky trap. It is very easy to follow along with a step-by-step solution and feel like you understand it while being completely unable to reproduce it on your own. Comprehension and ability are not the same thing. The only way to know you've truly got it is to do it solo. Technique 3. Don't rush. This is my last tip, and it's especially for anyone slogging through assigned homework. I know the temptation. I've even made videos about getting through work efficiently. But with math, science, and any genuinely complex subject, rushing actively sabotages you. When you rush, you don't master concepts. You brute force your way to answers, or you look things up, or you sort of cheaty face your way to a finished assignment. And then later, sitting in an exam room or trying to apply this in the real world, you get a very harsh lesson in exactly what you never actually learned. Speed on the homework feels like winning. It's a loan you pay back with interest on test day. So let's recap. To get better at tough math problems, first, identify the combination of concepts in a problem and isolate them. Work simpler, single-concept problems and master each one, where mastery means you can't get it wrong. You can also simplify by keeping the structure but swapping in small, easy numbers. If the concepts themselves are shaky, go learn from your book, example problems, or a tool like Wolfram Alpha or Symbolab, but only after you've truly tried, and always rework it yourself afterward. And finally, don't rush. Focus on mastering, not finishing. I want to leave you with a line from the physicist Richard Feynman, who put the whole spirit of this beautifully. What one fool can do, another can. It was his way of saying that anything one person learned to understand, you can learn to understand too. Math isn't a gift handed to a lucky few. It's a skill. And the moment you start solving problems and stacking up little breakthroughs, your confidence rises, which makes you tackle harder problems, which builds more confidence. It's a self-sustaining cycle. The only thing you have to do is start. If this was helpful, a like genuinely supports the channel, and maybe share it with a friend who's convinced they're not a math person. You can subscribe for a new video every week, and there's a free copy of my book on earning better grades in the description. Thanks for watching. I'll see you in the next one.